You know those huge, brilliant LED screens you see everywhere? The ones that can turn a whole stadium into a spectacle or a city square into a living piece of art? They're incredible. But behind every single one of those dazzling displays is a massively powerful and complex system. And, with great power comes great risk. So today, we're going to go behind the screen and explore the crucial system for safety that makes it all possible. So what does it really take? I mean, this is a question every single project manager, every engineer, and every technician has to answer. Because keeping a giant LED installation safe, well, it's so much more than just plugging it in and hoping for the best. It's about managing some very real and very serious risks. And listen, we're not talking about some abstract idea here. These are live wires and real dangers on every single project site. We're talking about old electrical circuits just groaning under a massive load, dangerously non-compliant wiring that's hidden away behind panels, and the constant threat of fire or electric shock. Even a tiny, unseen hotspot, something you'd only see with an infrared camera, could be the silent warning of a catastrophic failure just waiting to happen. Okay, so how do we even begin to manage all of this? Well, you start with a blueprint for the entire process. And that's where our first pillar comes in. ANSI, the American National Standards Institute. And this isn't just a list of rules. It's about building a safety-first culture from the ground up. And right at the heart of the whole ANSI approach is this really powerful idea, prevention through design, or PTD for short. Now, what this means is actually pretty simple, but it's also revolutionary. Instead of just putting a warning sign next to a hazard, you design the hazard out of existence right from the very beginning, see? It's all about being proactive, not reactive. And this isn't just my opinion. The standard itself says it best. The key takeaway is that the benefits are most significant when safety is integrated from day one. You're not waiting until the end to ask, is it safe? You're asking, how can we make this inherently safe at every single step of the way? And this visual here, it shows you exactly what I mean. Safety isn't some checkbox you tick off during the build phase. Nope, the ANSI philosophy covers the entire life cycle, from the first spark of an idea through manufacturing, installation, maintenance, all the way to when it's eventually decommissioned. Safety is a continuous thread that's woven through the whole project. And it doesn't just stop once the screen is up and running. The ANSI Z10 standard gives us this awesome continuous improvement cycle. You plan for safety, you implement it, you're constantly evaluating how well it's working, and then management reviews everything to find ways to make it even better. It's this dynamic loop that's always improving. All right, so ANSI gives us the how, the big picture process blueprint. But that blueprint needs a universal language for the what, the technical nuts and bolts. And that brings us to our second pillar, the IEC, or the International Electrotechnical Commission. You can think of this as the global rulebook that makes sure every component, everywhere, speaks the exact same language of safety. Now, a key concept that comes from the IEC is functional safety, and this is absolutely critical for the complex control systems running these giant LED walls. It's not about hoping a system never fails, let's be real, things happen. It's about designing it so that when it fails, it does so in a safe, predictable way. It fails gracefully, which prevents some minor glitch from turning into a major disaster. So how do you manage that? Well, the IEC gives us safety integrity levels, or SILs. Think of it like this. The SIL rating is a measure of how much you can trust a safety feature to do its job when you need it most. A simple little warning light might be SIL 1. It's helpful, sure, but not life-critical. But that giant red emergency stop button for a stadium-sized screen, that thing needs to be incredibly reliable. So it would require a much higher rating, maybe SIL 3, to prove that it will work without question every single time. And the IEC rulebook gets very specific. For example, standards like IEC 6364 set the global benchmark for the entire electrical installation. Meanwhile, IEC 61439 makes sure that the switchgear, which is basically the heart of the power distribution system, is built and tested for top-notch safety and reliability. Okay, we've got our process blueprint from ANSI and our global rulebook from IEC. Now we need the engine. Our third pillar is the IEEE, the Institute of Electrical and Electronics Engineers. This is what provides the deep engineering practices to make our system incredibly robust and resilient. So a huge idea here is protection and coordination. What does that mean? Well, imagine a single LED panel has a short circuit. Do you really want the entire screen in the middle of a packed stadium to just go black? No way. IEEE practices guide engineers to design a smart system where protective devices, like circuit breakers, isolate only the part that's failed, keeping the rest of the show running safely. IEEE really drives this home with a focus on three key principles. First, fault tolerance, which just means the system can handle a component failing without a total collapse. Second, redundancy, which is all about having backup power supplies or data paths ready to take over instantly. And third, system monitoring, which means the system is always checking its own vital signs, so it can alert operators to a potential problem before it actually happens. So we have these three really powerful pillars: ANSI, IEC, and IEEE. But their true power doesn't come from using them in isolation. Oh no. The magic happens when we weave them all together into a single, cohesive, integrated safety framework. Let's see how that works. First, we start with the master plan from ANSI. That's the process. Then, we bring in the universal standards from IEC. Those are the rules. And we power the whole thing with robust engineering from IEEE. That's the reliability. And this right here is where it all connects. We bring together the process, the rules, and the reliability into one solid strategy. Just look at how this plays out in the real world. For, say, a touring rental system, ANSI's process gives you standardized handling protocols to keep the crew safe. The ISC's rules make sure the system meets safety requirements whether you're in Berlin or Boston. And IEEE's focus on reliability means the connectors and relays are tough enough for constant setup and teardown. It's that synergy that turns just checking a box into true systemic safety. And that brings us to the final and most crucial question. Look, it's easy to just chase compliance and check boxes. But this integrated framework challenges us to do more than that. So as you look at your next project, ask yourself, is it just compliant? Or is it truly, fundamentally, and intelligently designed to be safe from the ground up?